Hello everybody, I will start my today's another coding practice. So today I will solve this question, trapping rainwater. I think this is a quite famous question and I've already solved this question multiple times in my life. Yeah, maybe once, twice, 3 times. Yeah. And yeah, today I will solve this question again with the explanation. Okay, so that being said, let me get started. So this question is quite simple. So I'm given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after rain. Yeah. Yeah. Okay, so that's it. And in this question, okay. So, okay, I will first clarify the question statement and also confirm the input. So the question statement is quite, clear. Yeah, with the help of this example one. So yes, thanks to this mapping graph, yeah, I can easily understand the question. So I'm giving the height list, and each height is represents the height of the bar whose width is 1, and it should be 0, 1, 0, 2, 1, 0, blah 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 in this case, and it rains above the bars. Then the bars trap some water, and yeah. And my task is to calculate and find out how many water blocks are saved, or I should say trapped. So in this case, there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 blocks. Yeah. So I will return 6. Okay. So yep. And it is guaranteed that the n, which is the height of length of the height blocks, I mean width of the whole bars, is at least 1. So there is at least one element in the given height list. Okay, that's it. So that being said, let me tell you the algorithm I can use. So in this question, I actually have 2 solutions. I actually still remember that. The first approach is using the prefix. Yeah, prefix or suffix max array. And the second approach is using the 2 pointers. And let me explain the first approach first. Prefix or n suffix max array. So when I'm given this height, okay, and let me see how much water I can trap from this. And or I should say, for each block, I mean for each x coordinate, the height of the water to be trapped, how can I decide it? So that's what I'm thinking first. And when I take a look at this, I mean, the index 2, the water block is 1. This is calculated from the, left side highest bar height, and also taking a look at the right hand side highest bar. So in this case, left hand side highest bar is 1, and right hand side highest bar, that height is 2. So with this 1 and 2, I will guess the mean of 1 and 2, and I get height 1. That's the water block height. And also I have to take care in the case of this one, the left hand side highest bar height is 3, and right hand side highest bar height is 2. So mean of 3 and 2 is 2. So it can trap up to 2 water blocks. However, one block is already not water, but some kind of solid substance. So I have to subtract 1 from this from the 2. In that way, 2 minus 1 is 1. So I guess the water block 1 to be trapped in this coordinate. Okay, so that being said, the task I will do is firstly, I get the prefix max array. So with the prefix max array, I can say, so for each index coordinate, I will get the highest, highest per height on the left hand side. So in this case, for the first element, it should be 0. It should be determined. And from that, it should be 1, 1, 2, 2, 2, 2, 3, then 3. Yeah, so it should be non-strictly increasing. And for the suffix max, it should be 1, then 2, then I will get 2 twice. I'm looking backward. And then I get 3. And after that, all of them should be 3. 1, 2, 3, 4, 5, 6, 7. I mean, 7 blocks should be the height 3. Okay. Then I get prefix max and suffix map. After that, for each coordinate, I guess the mini of this, which should be 0. And after that, I will decrement 0. I mean, subtract 0, which is the original, height of the bars. So I can say, so this is the water amount which can be trapped in the one coordinate. Yeah. So I do this iteration for each, index, and I will calculate the water to be trapped in each coordinate, and I get the total amount of water, for all the coordinate, x coordinate. So that's how it works. Okay. So in this way, time complexity should be O of n, and also space complexity should be O of n also. Because for time complexity, to build prefix max, it takes O of n, suffix max is the same, and then I do iterate each index in the end, so it should be O of n. 3 times, so O of n in total. For space complexity, I need prefix max, which is O of n, suffix max O of n, so in total it should be O of n. Okay, so that being said, let me get started with the implementation. So I will define the sub method to build prefix max array and suffix max array. Then after that, I will do the iteration. So how I can get it. So as I said, current amount is yes, so I can do it in this way. But I think it's a bit more easy to read if I use it in this way. So this is it. So I will build suffix prefix max array and suffix max array in some method. I will do that later. And after that, with prefix max list and suffix max list, I will calculate each index's trapped water in each index. And for each index, I will get the meaning of prefix max and suffix max. Then I subtract the height of the bar. Then I get the current amount. And I increment total amount by that current count. Then I will return total amount. Current amount. Okay, so this is it. So let me run my code. Oh, sorry. I said I will implement these two methods. So this returned array is the prefix max. So for each for each index, I will take a look at I-1, which is the previous prefix max. And also I will take a look at the current height. Yeah. So this is the current prefix max. So I will append it to the return array. Yeah. So this is how I get the prefix max array. Okay. Then what I should do next is implement the build suffix max. Let me implement it. Oh, wait. Yep. So this is it. So when I build the suffix max, I will take a look at the array from tail. So firstly, in line 46, I initiated the array to be returned. And firstly, I put the disposition number to be -1. No, 0. Then after that, I will traverse from the tail and -2, blah, 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 0. So for each, I can get current suffix max from the previous max and also compared it with current element height. So by getting the max, I can get the current suffix max. So I will append it to the returned array. Then I will finally, in line 53, I will return the array. Okay, so let me run my code. Int and non-type, I see. Oh, sorry, no, this should be it. Okay. Return is okay, and seems like array I is now non-type. Between instance of int and non-type. So now return I plus 1 is none. Oh, sorry. I did append, but I have to update it because I've initiated the whole returned array first. Okay, so now I've got the error. Let me take a look. I will print it out. Okay, so now I got prefix mark and suffix marks. Seems like this is correct compared with the example I displayed before. No, no, I think this wasn't correct. I should yeah, suffix marks. So I think this example was wrong because when I take a look at index I, what I want is the highest bar height in the right hand side, which is I plus 1, index I plus 1 or later. But it seems like now I'm seeing 0, 2 in the suffix max. Yeah, this is wrong. So what I can do is when I try to guess the index i's current suffix mark, what I should do is I will take a look at array I plus 1. Yeah. For example, if I'm looking at the index 2, I will take a look at the array index 3 because it's the new block bar which appeared in this iteration step. So now it looks like correct. But now suffix max array seems to be correct, but no, the answer isn't correct. So prefix marks is this and suffix marks is like this. And let me print out how much amount of water is calculated as the current amount. So when I see this, it should be 0, 0, 1, correct? 0, 1, 2. Oh, it says -1. I see. So the problem here is that if the like this. So if the current bar is the local maximum, or I should say higher than any other bar in the right hand side or any other bar in the left hand side, say current height is 3 and right hand side max is 2, left hand side is max. In my calculation, I would calculate that the max water amount in that index is mini 2 is 2. However, and after that, I subtracted 3 bar height from 2 and I get -1. But obviously this isn't correct. In that case, the amount of water to be trapped in the current index is 0. So here, current amount should be max of 0 and this. Okay. Then now my first example is accepted, but second one is not correct. So in the second example, let me take a look. Prefix max is, oh, this isn't correct. So yeah, the same. I think I should take a look at -1 because array I minus 1 is the new element which appeared in this iteration step. But still, I don't know why 4 appears first, but it doesn't appear. Oh, it's because 4 is ignored because of this mistake. Okay, good. So now I will submit this code. Okay, good. So now it's accepted. So this is the first solution using the prefix or suffix max array. Sorry, prefix and suffix max array. And the second approach, 2 pointers. I will talk about it. So when I get this, so basically I use the same idea. When I think of some specific index and try to calculate the amount of water which is stored in that index is the left hand side highest bar height, and also I will take a look at the right hand side highest bar height, and I guess the minimum of them. Then subtract the bar height of the specific index, then I get the amount of water. And to calculate that process, I can use the 2 pointers. And also, I would like to say, because I take the mini of the left side and right hand side, yeah, as long as the mini smaller side is calculated correctly, I can guess that what amount of water trapped in the specific index. So let me tell you what I mean with this example. So when I get 0, 1, yeah, something like this. Let me make it a bit smaller. Firstly, I can say this first index and last index, this doesn't trap any water. And what I can do next is, with taking a look at this, I can say currently in this range, the highest left hand side bar is 0. And highest right hand side bar is 4. And when I take a look at this 4 and 7, at least I can say the smaller side, 0, which is the left hand side. This 4 can trap 0 water. That's what I can determine. Because when I compare this and this, 4 and 7, sorry, 0 and 4, which appears so far, 0 is smaller. So the number which appears in the right hand side doesn't appear the minimum of these two numbers, and it always 0. However, for this part, this side, this is 4, and so far only I've seen only this element. But if say something big like 100 appears in this range, the amount of water trapped in this position should be more than 4. So I cannot determine. So that being said, I determine this index 1 with water 0. And then after that, I will update the suffix marks with 4 for index 1. And still it's 4. And if they're the same, so I can determine both of them, left hand side and right hand side, in the narrowed down range can be 4. Because any number which appears right or before the index I'm seeing doesn't affect the minimum of these two, prefix or suffix marks. So in this case, I will choose the first one, first index, and determine it. Then what I can do is update the prefix with 4 and 4. This is the same. So I still can decide either of them. Yeah. And I choose the first one. Then now I get 4 here. Oh, obviously I have to subtract 2 right there. Then I get the prefix. So let me make it bigger, like 8. So if I get 8, the prefix max at this position should be 8. So I can decide the tail one, last one in the remaining range. And it should be 4 versus 8, so 4. So in that way, I can use the 2 pointers and narrow down the scope. I have to decide the amount of water to be trapped. Then I can decide the amount of water stored in each index one by one. And I will guess the total amount of these coordinate, and I will return it. Okay. So that being said, let me quickly tell you about the algorithm. Use 2 pointers. If and use variables prefix max and suffix max. Yeah. And also I will use obviously left and right. And I will update prefix max, suffix max obviously, and the left and right should be incremented and decremented. And one thing I try to take care is move left if prefix max left is smaller or equal to the suffix max of the right pointer. In that case, move left. And I will move the right pointer otherwise. Okay, that's it. And for this solution, the time complexity should be O of n, because I use the 2 pointers and narrowing down the scope. And for space complexity, it should be constant. Yeah. So now let me start the implementation. So then I will pick like this. So in this way, the word to be trapped as the index left is determined as prefix max minus. So this is actually the height of the bar plus water in the end. But I have to decrement height left. Yep. And as I made a mistake before, if the height left is quite high, higher than any other element, it should be trapped with 0 water, not the negative number of water. So I will do this. Okay. Then I will implement left index. And also I will update prefix max. Like this. Okay, so now we'll take a look at right position. So I will do almost the same. Okay. Yep, so I think I can do it in this way. So one thing I will do, one more thing I will do is, I guess, I initiate the total amount and increment this total amount with current amount. Then I will return total amount in the end. Okay, this is it. So that being said, let me execute my code. Oh, sorry, this should be height right. Okay, now it's accepted, so I will submit my code. Good, now it's accepted. Okay, so let me quickly wrap up my today's practice. So in this video, I solved the question trapping rainwater. And in this question, I'm given a list of the integer which represents the height of the bars. And my task is if the rain pours into that kind of mapping blocks, how much water blocks can be trapped in that, buildings. And introduced two approaches. The first approach was using the prefix max array and suffix max array. And the second approach was to use 2 pointers. In either way, the basic idea is that when I take a look at specific index, the amount of water, I mean, the eventual height consists of block height and water height in the end should be determined by the left hand side highest bar height and right hand side highest bar height. And I will take the minimum of these two heights. Yeah, so that's it. So in that way, I can decide the water amount to be stored in that specific index by subtracting the original height of the bar from that amount. But one edge case I actually overlooked was the case when the specific bar I'm looking at, is the highest out of other bars in all the bars. In that case, many of left highest and right highest should be some value which is smaller than the current height of the original bar. So in that case, if I do the calculation of subtracting the eventual height minus original height will be negative. So in that case, I have to treat it as water amount 0. Okay, so that being said, let me finish my today's practice with this. Thank you so much. Bye.